Good day. I welcome you to ABP class. In this class, we are going to be talking about introductory chemistry. And in this class, we are going to be showing you everything that you need to know concerning chemistry. This class will show you what you will likely come through in future by studying chemistry. As a chemist, all these things that I want to show you are fundamental principles that you must put down as a note, and you must commit them to memory so that they will be part of you. As we'll be going through the notes, we'll be showing you basic things that you need to know. All these points are very, very important, although later we are still going to make a way in order to make our lecture up to examination period. In real life, when we are offering this tutorial, we always have Saturday classes to handle the advanced aspect of this course. But because we've just beginning, you have not received anything at all. We are not yet implemented that method. When we get to the point, you will be notified. Let's begin. Without wasting of our much time, what is chemistry? What is chemistry? Chemistry students, what is chemistry? You can see from this definition, it said that chemistry, it is the study of matter. That is, in chemistry, we are concerned with one entity called matter. When we are concerned with matter, we know that we are concerned with matter. What part of matter are we concerned with? We are concerned with composition of matter. We want to know the composition of matter. We want to know the properties of matter. And we want to know the changes that those matter will undergo. Those ones are not the only things that we need to know. They are not the only things that we need to know. We also need to know the uses of matter, which is on industrial scale. This is where chemistry become money. Now, if you can look at the word chemistry, you will see that it comes from the word chemia. Chemia, meaning cast together, pour together. The meaning of this is that your assignment as a chemist is to mix things together. You are mixing chemical, in short sense. Now, we have said that the matter that we are talking about depends on what? Composition, property, as well as changes. So in this case, we look at chemist as entity that look at matter. Under three things, which are what? Composition. We look at matter under composition. We also look at matter under properties. Because we want to know the properties of matter. We also look at matter under change. What type of change does matter undergoes? Now, for us to understand all these things, we need to understand some basic things about matter. And these things are the hierarchy of matter. The hierarchy of matter will tell us what are the entities that come together to form the matter that we are talking about. If you look at this table, we see here electron plus proton plus neutron come together to form atom. If you have watched our biology introductory class, you will see similar thing, but they are not exactly the same. Electron plus proton plus neutron come together to form atom. So therefore, in chemistry, we are going to look at these things in details, their discovery, their property, the experiments that they used, that they conducted to confirm their presence. We are going to be looking at molecule, because atom leads to molecule. Not that alone, atom can lead to ions, and atom can lead to elements. It depends on the path that atom take that will determine what it will become between these three entities: element, ion, and molecule. If the atom combine to become a neutral molecule, and these particular atoms, they may be homogeneous or not, they are called molecule. If they are homogeneous or not, but they are charged, they become ion. Ion is a charged molecule. And a charged molecule arises when one of the atoms inside the molecule loses or gains electron. Now, atom can also become an element if and only if the atoms are the same in nature. Molecule can come together to form compound. In fact, ions can also come together to form compound. That's what we call ionic compound. And also, elements can also aggregate to also form compound. But what I want you to understand in this structure is to understand the hierarchy, that atom is small compared to molecule, molecule is small compared to compound, compound is small compared to mixture. And you will see that this hierarchy is showing that what is ahead depends on what is behind. The meaning of this is that for us to have compound, we must have either a molecule, ion, or element. In order for us to have either element, ion, or molecule, it is necessary that we have atom in place. So what do we say? Compound come together to form mixture. We are going to look at this thing one by one. And because of the existence of mixture, we have what we call separation techniques. These separation techniques, the best way for you to understand them and to know them is to use alphabetical order, which separation techniques begin with C, which are three in nature: crystallization, chromatography, centrifugation. Which one begin with D? Distillation and decantation. There are two types of distillation. We have fractional distillation and absolute distillation. Now, which one begin with E? That is evaporation. Which one begin with F? That is filtration. Which one begin with G? The M, that is, there's no one that begin with G. There's no one that begin with L. There is one that begin with M, which is magnetic separation. CV begin with S and separation funnel, as well as sublimation. The last one is trapping. If you can remember each alphabet, you will be able to list all these separation techniques. And we are going to know the reason why separation techniques is very, very important as a chemist. Now, you can see along this part, elements can come together to form compound. Molecule and ion can also come together to form compound. When compound is split into two parts, we can have inorganic compound or organic compound. Whether they are organic or inorganic, everything is matter. So as an entity in life, you as a human being, you are an organic entity. The storage tank in your house is also an organic entity because it is made from polyvinyl ethylene compound. And polyvinyl ethylene compound is an organic compound, polyethylene chloride. Now, We also have inorganic compound. Example of organic compound is a nail in your house. The plate that you are using to heat, not the plastic one. The plastic one are organic, while the metallic one are inorganic. Your stainless plate. Your spoon. I'm talking of iron spoon, but your plastic spoon is an organic compound. Now, you know that compound can be inorganic or organic. And as we form every matter, matter exists in three states. That is, matter exists in three states. It can either be solid, liquid, or gas. When we are talking about solid, liquid, or gas, there is a property that we use to differentiate them. And when it comes to molecular property of matter, we are going to look at differences between solid, liquid, and gas with respect to the nature of bond, with respect to movement of intramolecular particles, with respect to whatever that is remain, size, shape as well. Now, when we have compound can mix together physically in a physical process to form mixture. Mixture is two or more compounds that combine together without undergoing any chemical process. Compound can also combine together under chemical process to form new compound entirely. Example of that reaction is acid-base reaction. I'm so sorry for a new beginner that you don't know what it means by acid and base reaction. But you can try this in your house. You can try this in your house. Try to have your detergent soap and try to add small liquid of orange, this small orange, into it. What you are trying to do is you are trying to add acid into base. You will see a kind of change. That is chemical process. Now, this chemical process occurs under what we call chemical combination. Under chemical combination, we are going to look at all the laws of chemical combination and how chemical combination actually occur. Now, let us now look at electron, proton, and neutron. What are they? What are the properties? Now, here, electron is a subatomic particle that is represented with this symbol, whose electric charge is negative. That is, electron carries negative charge. Now, electron belongs to the first generation of lepton. Don't worry about this. But what I want you to know that is very important here is that electron is subatomic particle. It is under atomic because the word sub means under atom. Subatomic, under atom. And particle means it's a small part under atom. So therefore, the electron is discovered by J.J. Thomson in 1879. They may not ask you of the date, but many examiners like to ask this question, that who discovered electron? It is discovered by J.J. Thomson. And they can ask you, what is the charge on electron? The charge on electron is negatively charged, but if they ask you, what is the amount of charge on that particular electron? It is 1.602 times 10 raised to power minus 19 coulomb. But the mystery you and I do not understand is, how does scientists determine this value? We are going to get to Millikan experiment. The next one is proton. It is also a subatomic particle, but this one carries positive charge. It is discovered by Eugene Goldstein. We are going to see that experiment. The last one is neutron. It is neutron, from the word neutral. No positive, no negative. It is zero. It has no charge. It's also a subatomic particle. The charge is zero, and it is discovered by Chadwick. But I must let you know by comparing the masses of these three particles, neutron, it is the most heavy one. It is the heaviest of the three. Now, when we look at neutron, the mass is about 1.6 times 10 raised to power minus 27 kg. Imagine how small that mass is. How do scientists determine this mass? The mass is very, very small. That makes this object to be invisible, and no human eye can see it. Look at the mass of proton. The mass of proton is 1.62. You can see 1.672. 1.672. This one is 1.674 times 10 to the power minus 27 times 10 to the power minus 27. So this digit is the same. But where the mass is different is this particular 2 and 4 here that show that neutron is more heavier than proton. And by looking at the mass of electron, the mass of electron is the least. Electron, it is the lightest subatomic particle. Neutron, it is the heaviest subatomic particle. This is the atom that we are talking about. If you could look at this structure, there is electron here moving around the nucleus. The nucleus is also called nucleon. And the nucleon, it is the aggregate of what? This proton and neutron. In this atom now, there are many proton and neutron that come together. So what happens is that we have this center particle, which is nucleus. That's the reason why we call it nucleus, because the word nuclear means center. And in this center, electron is moving around in an elliptical path. That part is called elliptical path. I must let you know that in real life, this line is an imaginary line. It's not really there. They just draw it to show you that electron move around the proton. So what do we have in actual sense is a big nucleus like this and small electron like this that is moving around the nucleus. So this is what atom actually represents in real world. Now, an atom, it is the smallest unit. It is the smallest unit of ordinary matter. The smallest unit of matter. That is to say, the smallest thing that we can find in a matter is called atom. Because we, as a chemist, we are concerned with the smallest unit of entity of matter that is responsible for what we are studying, which is change. And every change occurs at atomic level because it is the smallest unit of matter that takes part in chemical reaction. It takes part in chemical reaction. So the two phrases that are very important here is what? Smallest unit of matter. You may not put ordinary, so okay? It is smallest unit of matter, and the next one is what? Take part in chemical reaction. For you to have your full mark in definition of atom, these two phrases must be in your definition. Atom consists of nucleon, I have told you, or they can call it nuclei, which is the sum of what? Proton and neutron. It is the sum of proton and neutron, which is located in the center. Atom consists of electron, which is used in chemical reaction. That is to say, every chemical reaction that we are seeing today is due to exchange of electron between atom of an element. We are still going to get to that. So in this way, we compare our atom to planetary structure. Where there is sun in the center, according to Galileo, heliocentric planetary system. Helio means sun, centric means center, heliocentric, sun in the center, planetary system. This principle, this law, is stated by Galileo, and it states that sun is located at the center while other planetary bodies are moving around it in an elliptical path. This is one planetary body. This is another planetary body. This is another planetary body. So this planetary body is the one where you and I are, which is the Earth. So these are the list of the planetary body: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. The one that is very closest to the sun will have highest temperature because it's very close to the hot body. The Earth, where you and I are we inside the Earth or are we on the Earth? We are on the Earth. Everything that you see on the Earth today, the big plane, the big houses, they are on this structure. So if you can see us, we are inside, we are on a particular entity that does not have end, upper part, and that does not have end, lower part. What will happen to human being on the Earth if the Earth fall out of its own orbit? So therefore, because Earth is too big for us, we cannot feel the impact. If you want to see this planetary body and the way they are, what you can do is to go and meet some people that have traveled into the space to take you into the space. This is what we call space. And you will begin to see this thing when you have moved very high above the Earth. At a particular point, if you look down, you won't see anything again. So when you move high, that's the reason why scientists move high, not move down. If they move down, they are not going to see anything. It's like they are going into black hole. I don't know what is there. Maybe you can travel to that black hole and come and tell me what is there, but I don't want to go with you. I am very, very busy, you can see. Now, in this case, our atom and planetary body are actually the same in nature. This is like the sun, while those electrons are the planetary body. Now, what we are talking about here is that for every planetary body, electron is moving around the nucleus of atom, just like the way planetary body move around the sun. There are two types of movement. Number one, revolution. The movement of the Earth around the sun that results in 1 year, and we also have rotation on the axis. Also, Earth also moves on its own axis that results in day and night. So if you look at this, this is the Earth revolution. This is the movement of the whole body of Earth. We call it whole body movement of Earth around the sun. So this is the movement of Earth on its own axis. This one results in day and night. Now, I must let you know that this is the end of this class. In the next class, we are going to continue with the next line of action in introductory chemistry. But what you should take away in this class is for you to remember the hierarchy of matter and every entity inside it. It may take you time before you can have it within yourself, but in order to put it into your memory so that you can remember it offhand, what you need to do is to draw down the hierarchy and take it along with you. Any part you are going, look it once at a time. Before you know it, you will be able to commit everything to memory. Thank you for listening. This is abp.com.ng online tutorial center. Thank you for listening.